So I want to try to combine this one where I'm emitting the pigheads and this one where I'm emitting boxes and this system where I'm just spinning a soft body. So I didn't try this out already, so I don't know how it's gonna go. Okay, first off, I'm gonna start with where I'm emitting the soft bodies. And I think this system is gonna be my kind of basic system. And for now, I'm just gonna skip this point deformation. So I'm gonna copy these nodes. And I also need these two. This is the geo I'm referencing inside of here. And the constraints I'm referencing as well. So let's take all of these and these. Here. Okay. Instead of using this test geometry, I wanna replace it. So I'm just gonna delete these. And then I wanna pick up where I'm emitting the boxes. So I think I just want these. Okay. I'm not gonna be using this transform. Let's see these boxes. Yeah, there they are. Coming and going. Yeah. I need the normals to orient them. I need the p-scale. I don't want the W. That's the angular velocity. And what is this? If we wanted to grow, which we're not gonna do. Not right now. I might add it later, but it's gonna be a bit more complicated than with the rigid body. Actually, we can just keep it. Then I want to remesh the boxes. So I'm just gonna grab the remesh from the soft body spin. This one. Like this. Actually, let's just remesh it up here. So now we got some boxes. Yeah. Can remove this remesh. Let's plug this into our Vellum constraints. Let's try to play. Yeah. It's working, they're landing inside each other, which is fine. Let's see how it goes. Inside of the Vellum solver, I am going to remove the ground. So, no ground plane. And if we want to spin them, we can grab the warp from this one. So that is this warp. So I'm going to copy this node. And I'm going to put it after the copy node. Let's now see how this looks. Yeah, they're spinning, but they're all spinning in the same direction. So let's make it spin around a random direction. So up here, I basically want to give these points a random vector based on the frame number and the point number. So I'm just going to use an attribute adjust vector. This vector I'm going to call, I guess, piv for pivot. I'm going to set it to random. I want both positive and negative values, so it's going to be zero-centered. And the amplitude of 1 is good. So now we got a piv attribute that's random. And I want to add the frame number to the seed. So here I'm just going to say plus at frame. So every frame will give us a different value. In here, in the attribute warp, instead of this constant pointing upwards, making the box spin around the y-axis, I'm going to use the new attribute piv that has a random vector value. First, I'm gonna visualize the v attribute. And inside of here, you can see if we change this value, it's gonna rotate in a different direction. But instead of using this one, I'm gonna bring in the attribute, so bind. It's a vector attribute. It's called piv. And I want to normalize it to make sure it has a unit length of 1. So if you want to just take a look at it, you can plug it into V. You can see if we try different boxes that it's always pointing in a different direction. Let's try again. So I'm going to connect this to the cross product and then the multiply into V. I'm going to hide the velocity vector again. And let's see how this looks. Maybe you want to like decrease the velocity a little bit. Let's say 10. And let's add the collider as well. So I'm going to connect the collider to the third input, the collision geometry. I'm going to see if I can just use it like this, where we broke it up into smaller pieces. Let's see how that works. Like this. And if we connect this one, and to take a look at it, we can put down another null and connect it to the third output. So this is our collider. I'm just going to turn off the collision visualization for now, and let's see how this looks. So I'm thinking we should make the box keep its volume. I'm going to toggle the real-time playback here. So instead of having the boxes just fall in on themselves, I think I'm going to take the constraint we had earlier with the box. So I'm just going to grab these two constraints. So copy. And instead of this one, I'm just going to remove it. And then I'm going to paste these two in, connect it to the solver, then connect the collider to the third input, and then the geometry to the geo null, and the constraint to the con null. Now let's see how these look. Yeah. Maybe we can increase the attribute back to, what was it, 20? Here they're getting a little stretched because they're emitting inside of each other and then they think they're the same object, so I'll get some stretching issues. To fill it up faster, I'm going to revisit this remesh node. And I'm just going to set the target size to 1. I guess we could write it out to disk. And then I'm going to save the scene. And I'm going to use the save to disk in background option. So now it's starting a background render. Let's look at it in the scheduler. 1%. I'm going to bring it back in with a file node. It's inside of Geo, and here we have them. How many we have so far? 150. Yeah, it's gonna get slower the further in because we're always emitting more and more spheres, so it's heavier to handle. Might crash at some point, but let's see. We could give them an attribute based on their connectivity. So class, you can see it here. And now if you use that for color, You can see we got a lot of intersection, and that is because they are intersecting as they are emitted. So like before, we would have to emit in a better way. Halfway through now. Here, yeah. Now it's getting stuck in the collider. So I guess it's just gonna hang there. Yeah. And now the new ones might get stuck in that one. I'm gonna kill the simulation, and up here in the points from volume, okay, I'm just gonna take this down. What if you use a relax iteration? And then we take this down to 3.3. A little higher. 10. So this is gonna even the points out so they're not too close to each other. Let's see how this looks. Yeah, a lot of them get stuck in the collider, which is fine. Let's just make this sphere a little smaller. Like this. Let's try again. It's still getting stuck. Instead of making them this big, I'm gonna make the biggest one only be 50% bigger than the smaller ones. Still some intersection going. Maybe we can take this value even higher. Since we're using the scatter density, I think this value is different somehow. Let's try 25. $30. So I'm gonna spin them and push them down a bit. So back in the attribute WAP. So if we find a box and look at the velocity, they're all over the place. So I just want to add the negative push to it. So I'm going to put down a constant. And it's a vector. I'm going to add it to whatever is here. And let's set it to -1 in y. Maybe -5, 10. Let's see how this looks. So it's not only spinning it, it's also just pushing it down. So if you connect this to y directly, it's just down. I'm going to turn off the visualization and let's play again. So I'm kind of trying to push them out of the way so they don't intersect as much. Let's try to save this to disk. So again, I'm going to save the scene. I'm going to say save to disk in background. I would like to overwrite the old cache, so erase and replace. Open the scheduler. This is our old one that we cancelled, so here is the new one. Yeah, I think these collisions are also probably causing the simulation to slow down a lot. So I'm just gonna kill it. Let's try one more time. Let's go up here. And I'm just gonna make this, put it a bit further down and make it a bit smaller. You can also make it a bit thicker by increasing this one. And again, I'm just gonna overwrite. So here I save the scene and save to disk in background. Erase and replace. Okay, we have it here. 20 frames so far. 150. And now we got the other one here. And if you want to take a look how this points from volume node works, you can just go into it. And if you want to make any changes, you can right click and choose allow editing of content. Then you can go through all these different operations. So we have 600 frames here. So no one is hanging in the ceiling yet, like we had before. And I think it's going a bit faster. Earlier it got stuck around 64%. So it seems to be a bit better, but on the other hand, we don't have as many spheres. And the render is complete. Let's take a look at it. And then the last thing to do is to have them start off a bit smaller and then having them reach their full size over the first few frames. So if you take a look at the attributes, we do have the born attribute. So that's perfect. And back in the system where I'm emitting the RBDs, I'm just gonna grab this attribute WAP, this one. So copy. And in here, we don't have to unpack anything because these are not packed. And now, this won't exactly work. It works in a way, but they're moving weird at the beginning. And that is because we don't have this PIV attribute. This is the attribute that we created from the boxes while they were still packed. And we don't have it in this one. But let's see if the fit is working correctly. So I'm going to plug it into color. And you can see the boxes start off darker. We can even take this to 0 to see it better. And then become lighter in 10 frames. So that's good. That's still working. So instead of using this PIV attribute, I think I just want to do each box separately. So I'm going to use a for each loop and choose for each connected piece. So this one will again give us a class attribute here. And in this case, it makes it a primitive, which is fine. We can even take a look at it with the color node. So we just have to change it from class point to primitive because now class is a primitive attribute. So it's gonna loop over these and work on them separately. This is, I think, the first one. Yeah, the one that has class 0, but it will then collect them all back up again. So I'm gonna take my attribute wrangle and just put it inside of here. So right now, if we remove this, it's still not great because it's using 0 as the center. But what I'm going to do instead, I'm going to grab the bounding box or whatever this geometry is. That is the geometry just coming in the first input, so it's basically just this box. So I'm going to put down a bounding box node. And this will give you the min P, X, Y, Z and the max P, X, Y, Z. So the min Z, max Y, min Y. And if we take the average of these, we will get the center. So if you just plug this into P, you can see it's inside the center of the sphere. So if you go upstairs and just template the box, it's actually in the center. But I don't want to do that. I only want to use this as the pivot. So in here, I'm going to connect this to the pivot of the X-form. And then I'm going to connect this to P. I'm going to get rid of the color. And again, I don't want them to start all the way at 0. So let's say start half the size or half the scale. And remember, this goes into the scale of the transform. Then upstairs, I think this should work. I didn't try it before, but let's see. Yeah. Just gonna template the sphere. Yeah. Yeah, so they start off small and increase their size. Let's make another flipbook.